What is a function? So suppose that we have two sets of numbers, right? Or we have one set, right? So let's say that we have what we call our input set of numbers, right? So we take in values from this input set. This is what we start in with here. So if we consider it to be like um, the number of times that you run an experiment, you run it one time, two times, three times, four times, right? So this input set here, right? This is what we call the input set, right? Or a special name for it is what we call the domain, right? So the input set of the domain is the numbers that we starting off with. Now, let me say we get the results of the experiment, right? And we have the set of results, right? And again, this is just a general example, right? So this input set, it gives us an output set, right? So let's say that the output set, I give us values like this here. Let's go with 5, 10, 15, 20, right? That's an easy numbers to go with. So this output set, right? It was dependent on the values of the input set first of all. So the name of this general output set is what we call the codomain, right? So these two names it should get used to, right? Domain and codomain. Now, there's another name for those who are a little bit more advanced. You will know the name range. We'll talk about what the range of a set is a little bit later on, but not right now, right? But the general input set of values, what we call the domain. Now, in maths, to make things a little bit easier, we say that this input set is the set of x values, right? Just to make it a little bit easier to work at. And similarly, the output set, we call it the set of y values, right? Now, again, those x and y, they are just names given to the specific thing. This could be, as I said, like the amount of times that you run an experiment, the first time, second time, third time, fourth time, or it could be like um, time. You're looking at the amount of minutes. So when time is 1 minute, the speed of a vehicle is 5. When time is 2 minutes, the speed is 10. When time is 3 minutes, the speed is 15, and so on. Right? So these are your variables. Right? This tells you what your variable is. So the variable here is what you call x, right? And the output is typically what you call y. Now, if we look at each one of these here now, right? So 1 to 5, um, 2 to 10, 3 to 15, and 4 to 20. Right? We try to see if there's a relationship between each output and between each input and its corresponding output. Right now, if you look and see if you see a relationship, right, we know for each input value to get the related output value, what do? We just multiply by 5. 1 by 5 is 5, 2 by 5 is 10, 3 by 5 is 15, 4 by 5 is 20. So the general rule, right, to get from the input set to the output set, you multiply each input value by 5, right? So the rule is you take your input and you multiply it by 5, right? So this rule or this instruction is what you call a relation between the input and output sets, right? So a relation, right? And again, this is just a general overview of what it is, right? The teacher might give a little bit more specific version, right? But a relation between, or a relation is a rule, right? And is a mathematical rule, is a mathematical rule which takes an input, which takes an input and gives an output, and gives an output. Yeah. And as it does, all a relation is, it tells you what rule that we use. So the rule here, right, to go from our input set to our output set is that we take our input, each input value, and multiply it by 5. Yeah. So what we need to know how to figure out what the rules are. But for the most part, the rules on them are generally easy to see, right? And then we have to know how to, we have a few different things I need to know about the rules as we going down, right? So let's go again. Now, again, as usual, feel free to pause at any point um, to to try and understand it a little bit better, right? So let's go again. Let's say that we have the numbers, right? Just so that me being a little bit lazy here. All right, let's go with 7, 5, 7, 9, 11. Right, so a set of input values here. This is again, this is your domain. You just follow the arrows, right? The set where the arrow coming from, that is called the domain, and the set where the arrow is going to is what you call the codomain. Oh, by the way, this type of diagram is what you call an arrow diagram. Some people call it a bubble diagram, but generally it's called an arrow diagram. Right, so let's see if we can figure out what the rule is here. All right, so right, yeah. So what do you do to each input value to get the output value here? Right, the rule is, and you can always pause the video to think about it. Right, so the rule here is that you take each input value, and you multiply it by 3. 5 by 3 is 15, 7 by 3 is 21, 9 by 3 is 27, and 11 by 3 is 33. Yeah, so that's your rule, right? So the rule or the relation, right? The relation is to get the output, right? The output, how do we get the output? To get the output, it's a like low domain, right? So to get the output, which is the output set here, you take the input set and you multiply it by 3. Now, there should be an easier way to write this, right? Now, how we, there are a few different ways that you can write this, right? And I'll show you all of them now. So sometimes you will see an overarching arrow here, right? So let's take this off here. This arrow here, and you will see a letter on top here, right? Let's call this, sometimes, most times you'll see F, right? And I explain why we use F in a little bit, right? So what we, so F here, this value here, this letter, right, is not a variable like X and Y. What this letter tells us here, this just gives us the name of the relation, the name of the relation, right? So we call this relation F, right? So another way to write the relation is this here, or we say that F, so I write it out in words, is such that X is mapped onto right, or the input, sorry, the input, let's go with the input. The input is mapped onto the input by 3. Yeah, so now what this means here, what is the meaning of the word is mapped onto? Because I had to use this word, right? It's feeling weird and disjointed, but it is a word that we tend to use and it makes sense in the context. Mapped onto means that this is what you do with the input, right? So there are a few things that we have to break down here, right? So I'll underline each of them. Is such that is an important word, on a phrase, sorry. Input by itself is an important phrase, an important word in this case, sorry. Is mapped onto, and then last one is the input times 3, right? So let's break down each one of these here now, and you can see where the names or where these weird things and functions come from, right? So F is the name of the function, right? So what is F? F is the instruction, right? Now, is such that in maths, you could use this colon, right? Is such that, that's what this colon means here. So from now on, if you need to write the words is such that in maths, you could just use this colon here. So F is such that, or F is the function such that the input. Now, what is the input? The input, remember, we call that X. Each of those are X values. So instead of using the word input, we use X, right? Now is mapped onto, it have a nice little symbol for that whole thing. We could use an arrow, right? So what this is telling us is that the function f, it takes the input X, and how do you get the output? You take the input and multiply it by 3. So it'll be X multiplied by 3, right? Or to write it a little bit closer together so you can see it a little better, f is such that X is mapped on to 3X. Remember, X by 3 means 3X. Yeah. Now it have one last way this map is written, but you have to know it in all the ways, right? And this last one now is written like this here. Is equal to 3X. And that's what this means. So again, just to break down what this is telling us, right? This here, it represents the output, this whole thing here, right? Now this is telling us that the relation, how the relation is that you take the input X, and to get the output, you take X and multiply it by 3. So let's break this down here a little bit more now so you can see it a little bit better. Right, and remember, you could feel free, pause the video, go back, and you will learn a little bit better, right? So this whole thing here, right, this whole thing here is the name of the instruction, right? So this is the name of the instruction, right? We say f of x. How we read it, we pronounce it as f of x. Right, so I don't want to, hear all this saying fx. It is f of x. That's how we read this here. Now, this inside here, it tells us what is the input, right? X is a variable, so it just means it's a number. X could be 1, X could be 2, X could be a million, right? It all depends on what set X comes from, but we'll talk about that. In this case, X could be any one of these values. X could be 5, X could be 7, X could be 9, X could be 11, right? And this here now, this is the instruction of how to get the output. So this is how to get the output. So that is the actual relation there, right? The name of the instruction or relation, right? Remember, it's a relation, right? So that's what this is here. So this is an instruction, and it tells you when you are given an input, how to get the output, and that's it. Yeah. So let's go. So let's go down now to see some different examples. Right, paste that there. Right, so let's go again with the example. Right, I just being a little bit lazy on copying and pasting. So let's say that we have this rule now, right? Again, this is our input set. Again, our input set is called the domain, and our output set is called the codomain for now. Right, the codomain gets a little bit more specific when we start to deal with range and things. So let's say here that our relation, right? We call the relation P, it can be any letter, right? Let's say P of X is equal to 2X minus 1. So let's start with 8, 12, 16, 20. Now, you don't ever have to go in order. It could be any number, right? All the input set depends on the question. So what is P of X? You notice what I say, I'm not saying Px, P of X, right? So what is P of X telling us? This is telling us that this tells us what to do with the input to get the output value, right? So remember this expression here, this is your instruction. Yeah, so this is the instruction. So what we do is we take that, sorry, all right, just 1 minute. We take each input and replace it with X, right? Because this is the instruction. So how do we get the output when the input is 8, right? So wherever it has X, you replace it with 8. So the output when x is 8 will give us, wherever it have x, just put 8. So we pronounce as P of 8, right? So it tells us the output when the input is 8. That's what this means. P of 8 is 2 into 8 minus 1, which is 16 minus 1, which will give us 15. All right, sorry, but this means 2 brackets 8, it means multiply, right? 16 minus 1, and this will give us 15. So just to write a little note on this idea, P of 8, what does this mean, right? It means, right, what is the output? The output when the input is 8, right? So that's it. That's all P of 8 means, right? So the number that goes here is 15. Let's go again. Let's try what is the out this number here. What number goes into here, right? What this is the output, right? This is the output set, the codomain, when the input is 12. So P of 12 is 2 into 12 minus 1, right? 2 by 12 is 24 minus 1. This will give us 23. Yeah. And well, you could always pause the video to try and figure out these two here, right? But feel free to pause the video. And since you tried it, 2 by 16 is 32. 32 minus 1 is 31. And then lastly, 2 by 20 minus 1 will give us 40 minus 1 is 39. Right? And this here is what you call the arrow diagram. So this is functions, right? Well, not functions, relations, right? So we didn't go into functions. A function is a specific type of relation, but we'll talk about those in a little while, right? Let's go again. Right. So right. And again, you can feel free to pause the video at any point. I know that it'll be fairly long videos now, right? But they will be worth it. Right. So let's go again. So let's say that we can bring any kind of numbers into this, positive, negative, and so on. All right, so let's go with -1, -2, -1, 0, 1, and 2. Now this is where things gonna start to get a little bit trickier now. All right, so let's say now that the function, that the relation, sorry, I keep saying function, that the relation is g of x is equal to x squared. Now, what this tells us, it tells us in order to get, remember, these are your x values and these are your y values, or what we call the g of x values. To get our output values, right? Remember, this is your input or your domain. This is your output or your codomain set. To get the output, you just square each input. So we want to square this -2, right? So g of x is equal to x squared. This is the instruction of how to get the output. So g of the first input number is -2. G of -2 is, now you have to be very careful with this here. A little note here is when you are substituting any number, you should ideally put it into brackets. You see what I did up here? Every time I replaced x with a number, I put it in brackets, and this is important. A lot of people have made mistakes here with that. So this will be -2 squared. Now, -2 squared, anything squared means that's something by itself. So -2 squared is really +4, because -2 by -2 is +4. So this is 4 here. Nice and easy, nothing too bad, right? We want to get the output when the input is -1 now. So g of -1, because x now becomes -1, it is -1 squared. Anything squared is that something by itself. -1 squared is -1 by -1, which gives us +1. Let's go with 0. G of 0 is, you just take wherever it have x, you replace it with 0. So it'll be 0 squared, and that will just give us 0. The g of 0 is nice. All right, now let's go now to this here now. What is g of 1? or what is the output when the input is 1? Again, that's what this means here. So the output, when the input is 1, you just take, again, you look at the original function, the instruction, right? So that will give us 1 squared, which is 1. Right now, we can put 1 here, but we try to reduce the amount of work that we're doing, because check something here, and we have 1 already in the output set. So what we could do, we could actually draw an arrow going from here to here, right? We try and draw a straight arrow here instead. So yeah, so we get that there. The output, sorry, when the input is 1 is also 1. So relations could also share values, right? And that's fine, but they have different names for these relations. We'll get to know this in a little bit. And again, the output when the input is 2 is 2 squared, which will give us 4. Right? So you notice that you're going to get another repeat here. And that's quite okay to get repeats. All right, and you will get a 4 here. But the arrows, they 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 tend to repeat themselves and whatnot as we go on. Right? So depending on the type of question and the type of relations that we're looking at, you will you will have a different name for it. Right? So this here is your relations and how we get into it. So let's do a couple more. Right. And with this one here coming up, I will give you some, well, I won't give you time. You can pause the video and try it out for yourself. All right, let's use the same 1, 2, 3, 4. And let's go with this one here. And let's say that the input is f of x is 3x minus, let's go with actually 5 minus 2x. All right, so feel free to pause the video and try to figure out what numbers go here. So if you pause the video and you try them out, right, you could write them down to the side. Some people tend to work it out in their head. You know, in maths, we always suggest that you show you're working, because sometimes you end up with a conclusion that happens to be the correct answer, right? But it wasn't the correct thought process. Not that we only want one thought process from here, but your thought process wasn't correct. So, you know, we need to see, especially when you're doing homework and so on, what your thought process is to make sure that you're on the right track. It's fine to use different techniques, but just make sure that it's correct, right? So we want the output when the input is 1. So f of 1 is 5 minus 2 into 1. You just look at the instruction and replace x with 1. Replace x with 1. Again, this doesn't mean 21. All right, to decide for those who are unsure, 2 brackets 1 means 2 multiplied by 1, right? So this will give us 5 minus 2, which 3 is the answer here. All right, let's go again. F of 2 means 5 minus 2 brackets 2, which will give us 5 minus 4, because this is 2 by 2 is 4. This will give us 1. Right, f of 3 is, again, this is the output when the input is 3. Whatever number is inside here, right? Whatever number is here, that is the input at that point, right? So this is 5 minus 2 into 3. Now you're going into negative numbers. 5 minus 6 is negative 1. And last, you know, f of 4 is 5 minus 2 into 4, which is 5 minus 8, which will give us negative 3. Right, so this here is your relations. I know when we talk about functions, it's just a specific type of relation that we do it. Right, so I want to give you a few questions just for you to try out. And feel free to to try it out for yourself. Right? So feel free to try out these two questions. And with all the questions, I'm gonna call this exercise one. Exercise one. At the end of the video or the end of the series, because it's a full function series are trying to do. It shouldn't take us more than about 4 videos. I will post a video with all of the answers. You can feel free to go through that. Right? Or if not at the end of this one, I'll work it out. Right? Sorry about that. Let me take this off here. Right, yeah. All right, so you can feel free to go through this and try it out there. So this here is what a function is. Not a function, sorry, a relation is. It is just a rule. This is your relation that tells you what to do with the input in order to get the output value. Right now, sometimes we will have to talk about how if we are given an output, right? How do we find back the input, right? But those are things that we'll get to in a little bit. What we want to talk about first, though, is the type of relations that we deal in, right? So of types of relations, types of relations. So, as we saw above, not all relations look like this, where you have an answer, each input has its own output, right? Look at this one here. This one, -2 and 2, they are both completely different inputs, but they have the same output, which is 4, -1 and 1. They are both completely different inputs, but they have the same output, which was 1. So sometimes you will have overlaps, right? So we have to learn about the different types of relations. And this is important here as we do in functions. So the first main type of relation that we have to learn about is what we call a function. And you would have heard me mixing up the words before because a lot of the relations that we deal with in maths, right, they are functions, right? But again, but not all relations are functions. Relations are the big overarching set. All mathematical relations we consider in these relations here now the relationship between two sets, right? One of the types is a function, right? Now a function is a special type, and I'm gonna show you some examples of how a function works, and we'll see if we can get it out from there. All right, so all right, so let's say that we have this here 1, 2, 3, 4, 5, 6, 7, 8, right? Right, so I'll just draw a few relations, a couple of functions here for you, right? And these are relations, but they are also functions. So let's look at all 3 of these here, right? Now I am telling you that all 3 of these are functions, right? What I want you to do is to pause the video and try to find relationships between them. Obviously not that they are all arrow diagrams, right? I want to see if we can find a relationship between all of them. Look at the amount of arrows. See if you could figure out for yourself what is a function. Why are, so the names of, I'll just call them random names, right? This is F. We'll call this one function B, and we'll call this one function T, right? Why are all of these relations, they are all relations, right? But why are all of them functions? So feel free to pause the video before I explain it to you. So if we look at these here, right, these two look very similar. Other than the amount of elements they have, we notice that each input has an output, right? And that's important. Now in these two, each output is mapped onto exactly one input, right? But look at this one here. I am seeing that this is also a function. But you notice that, look, we have a little straggler outside here. Now, let me show you what we call a non-example, right? So this one that I'm going to draw up here for you now, this is a non-example, right? It means that this is an example of, it is not an example of a function, a non-example. right? So another example, let's go with 3, 5, 7, 9, 2, 4, 6. This is not a function, right? So this is not a function. So again, feel free to pause and see if you can figure it out now that comparing these four, right? This one here is a non-example. It shows you that this is one type of relation which is not a function. Yeah, so feel free to pause the video to figure it out. So what we see here, right, is that for a relation to be a function, right, is that each input value must have, or what we call be mapped. It must be mapped onto only one output value, right? And that is very, very important. It must be mapped to only one output value, right? So that's what a function is. So let's see, right? So let's write that down. A function, and now remember, a function is just a type of relation, right? So a function is a relation, and that's very important, right? A function is a type of relation where each input value, where each input value is mapped onto only one output value, right? So each input must be mapped onto only one output value. So let's look at a few examples now, and you try to figure out if they are or if they aren't functions. Right, so each one of these now, so let's look at them and decide, are they functions? Now, importantly, what we'll need to do, we will need to have this definition handy here. Right, and this is the definition for a function, and I'll keep copying and putting across it so we can look at it, right? So again, a function is a relation where each input value, remember where the arrows are coming from, that is your input set, right? So all these sets, the input set is the leftward set, right? So we want to see if each input value is mapped on or has only one output value. So basically, the way to look at it from an arrow diagram is if each input value, right, is each input element has only one arrow coming out of it, then, and that's the important thing, right? So let's see. It has to have exactly one. So 1 is mapped onto 5 only, 2 is mapped onto 6 only, and 3 is mapped onto 7 only, right? So this here is a function, right? So this is a function, right? This one here now, so let's see, right? Each input value, so this is our input, so 8 is mapped onto 24, 9 is mapped onto 27, 10 is mapped onto 30. But this one here, this 11 is an input value and it is not mapped onto anything, right? So this is not a function because this input value is not mapped onto an output value. Yeah. No, this one here, no. Now this is where things start to get a little bit tricky, right? This here, this is a function, right? Because think about it. Each input value, 12 is mapped onto 6, 14 is mapped onto 7, 16 is mapped onto 8. Each input value is mapped onto only one output value. It doesn't matter if you have an output value which doesn't have an input value, right? This here is inconsequential to whether or not this is a function, right? So this one is a function because each input value is mapped onto only one output value, right? So don't really take into consideration output values. It only a function, the definition of a function, or if something is a function, only depends on the input values. As long as each input value has only one arrow coming out of it, it is a function, right? So think about this one here. What do you all think? Feel free to pause and think it through. Right, so for those who pause and think I thought it through, you could see that 10 is mapped onto only one value, 9 is mapped onto only one value, 8 is mapped onto only one value, which means that this is also a function. Right now, with these two, let's just paste back the definition here. Right, so pause the video and try it for yourself. Think about these two. Are they functions? Right, they may not be functions, but are they functions? Right, feel free to pause the video and think about it. Right, so if you pause the video and you thought about it, a function is a relation where each input value is mapped onto only one output value, or where each input, using an arrow diagram, where each input has only one arrow leaving it. Yeah, so this 2 has only one arrow leaving it. This -2 also has one arrow leaving it. So what we see here is that each input, they have only one output. The definition never said that it has to be a unique output. They never said that each input must be mapped onto its own output value, right? It just has to be mapped onto one. 2 is mapped onto only 4, and this -2 is also mapped onto only 4. So actually what this is a function. Right? Now we learn about what type of function this is in the following video. This here is actually called a many-to-one function, a many-to-one relation. Right, but we'll get to that. And let's check out this one, This one is mapped onto only 5, 7 is mapped onto only 5, 10 is mapped onto only 5. It's okay that the inputs are sharing an output. This is still falling within the definition of a function. So this is a function. All right, now let's look at these last two here for the end of this video. The last two here now. Again, feel free to pause the video and think it through for yourself. Let's paste the definition once more. All right, so go ahead and think that one through then. So for those who pause the video, again, just going back through one more time, a function is a relation where each input value is mapped onto only one output value. Now, only could be replaced with exactly, but we're not getting into that right now. 2 is mapped onto 3, remember this is an input, but 2 is also mapped onto 4, and it is also mapped onto 5. So this 2 has 3 arrows coming out of it. But to be a function, each input must have only one arrow exiting it, right? You must only have one output element per input value. So this here is actually not a function. This is another type of relation, which we'll talk about later on. This is what you call a one-to-many relation, right? And similarly, 12 is mapped onto 7, 10, and 11. So this is also not a function. So just to clarify what we did today, we learned about what is a relation, how to figure out values of relations, the 3 different ways in which we could write relations, and also we learned about what is a function, where a function is a relation where each input value is mapped onto only one output value. So just to end off with one last question for you to see for yourself, right? Let's just test yourself here. And you will let me know if this is a function or not. Well, not me, but you let yourself know if this is a function or not. All right, let's go 2, 4, 6, 5. All right, so think it through. All right, feel free to pause the video, scroll back up. You can see the definition. Actually, I'm gonna write the definition here. All right, actually, you can probably remember the definition. So remember the definition of a function is each input value must have only one output value. So is this a function? So this 2 is mapped onto 5, and this 4 is mapped onto is mapped onto 1. right? But this 6, which is an input value, is not mapped onto anything. So this here is not a function. And that brings us down to the end of this video. So be free to check out the next video, which gives us a few more types of relations. And we'll go into some more calculations when it comes down to functions. So until the next video, everyone, stay safe and keep practicing.